let's start with convolutional neural networks. So in this lecture, we'll see like what are the different basic like building blocks of convolutional neural network, and like what's the fundamental operation which is being performed inside these networks. And then we'll also have like a case study. So in the agenda we have, first we will talk about like the overview to give you like some high level idea where these CNNs are used. And then we'll try to go through some of the basics which we have already covered like in the past lectures, but which is relevant to this topic. And then we will directly jump into the fundamental operation, which is the convolution operation, or you can say correlation operation. And then some practical considerations, like some things which you should be aware of when you're designing a neural network. And finally, a case study where we'll take like a well-known CNN architecture and try to understand like how it works and what are the different components there. So let's start with the first segment, which is the overview of CNNs. And before that, like some very interesting example to you. This is just a joke, so not part of the lecture. So these days, like when you're working on deep learning, usually like it's very fascinating, right? A lot of people, I mean, they're very interested, and most of the fields are actually interested in this area, and they're trying to use deep learning into their research. Okay, and for the general society, it's like a very big deal, like the kind of impressive results we have. And so this is just like interpretation, what different segments of the society thinks about like when you're working on deep learning. And this is also interesting because the deep learning job market, it's so hot. When you will see like when you graduate, like it will give you like very high paying jobs, and the job market is really good at this time. And other scientists, I mean, they might not be like getting that much of like in terms of salary. And this is also interesting because mathematicians, like everything they do, it's like well grounded in theory. But you will see like in deep learning, when you design your networks, when you train your networks, of course, we have like some kind of mathematical background, but most of the time there are a lot of heuristics involved. So a lot of hit and trial. So that's one of the like limitation of deep learning at this point. And a lot of researchers are actually working on grounding like whatever findings we have, the interesting findings, to some kind of theoretical background. And if you think of yourself, you know, and this is a very famous scientist, Jan LeCunte. So you think you're doing something great, but actually most of the time, you will see in the programming assignment as well, you're just using existing code, right? You will see like if you use PyTorch, you're just importing like different library functions. And even for training, you don't have to write a lot of code. So basically it's not like a lot of effort, but this is a different perception, like different segment from the society has. Now, another motivation for you, I think some of you might have seen like this in the news articles. In one of the like art contest, someone actually created this image using AI. And this was, I think, some version of DALI model. And this actually won the prize. And the artists were really not happy about this because, I mean, even though this looks really nice, but I mean, no one created this, right? It's just like AI generated. So something to think to think about, but this is exciting. And these days you will see like a lot of people are actually trying to do that. They are creating these arts and they are selling them online, and they are sometimes getting paid a lot. Okay, so that's one aspect. But if you look at like the results, I will show you like one simple example. And the problem here is, given a video, just a monocular video, can you estimate the depth of each pixel? And the problem says like, in this video, like whatever pixel you choose, can you tell like how far that pixel is from the camera or the camera viewpoint? And I will show you example like a CNN-based model can actually do a pretty good job. So the animation on the right, it shows like the depth of each pixel, and you can see like if you compare that with the input video, it's actually doing a very good job. And with like so there are a lot of applications of this depth estimation. One interesting application you can see is like you can actually create a stereo effect, because if you have these sequence of frames and you know like depth of each pixel, then at like certain time step you can actually kind of extrapolate or predict like what are the hidden pixels, because you know the depth, right? So this is again just one example or one application of depth estimation. There are a lot of others as well. So I think this is a pretty cool example to show like how powerful these CNNs are. Some more motivation. This is like the problem is super resolution, and the idea here is given an image which is like very bad resolution, which I'm showing you on the left. But you can see it's a very pixelated image, and you can use CNNs to actually convert it to a very high resolution image. So the input is on the left, and on the right, it's like as the model is being trained, how the noise is actually being converted to the high resolution image, and you can see like the final result. It's really amazing, the quality of it. Okay,